Okay. Gravel is being poured off a conveyor belt onto a conical pile at a rate of 10 feet cubed per second. The height of the pile is increasing at a rate of 0.2 feet per second. How fast is the radius of the pile increasing when the radius is 3 feet and the height is 4 feet? Round to the nearest hundredth. Okay, so
Are these two different questions?
we're gonna be able to do it all in one. Yeah, but you know how I kept on kind of alluding to this? We're saying like, wouldn't that be annoying if we had to use the product rule? That's what we're gonna be stuck with now. Yeah. Okay, so let's draw our picture. So it's being poured off a conveyor belt and it's turning into a pile. And we're approximating that to a cone. Okay, so what do we know? We know dv dt. Which is equal to 10 feet cubed per second. We also know dH dt. And what's that? That's going to be 0.2, right? Or 0.02 feet per second. We kind of know the radius. Yeah, so we're interested in when the radius is 3 feet, right? So I'll put in 3 for now. But that's going to be at a specific moment, right? That's a changing value. And we know the height is 4 feet. And we are after how fast the radius of the pile is increasing. So we're after dr dt. All right, so let's write our equation. So our equation is V is equal to 1/3 pi r squared times h. And now, can I throw the numbers in? Can I throw in like 3 for r and 4 for h? No, both of these numbers were at a specific time, right? That's a changing value, and I want to know after I take the derivative, right? So those can't go in yet. So I'm kind of stuck at this point where, you know, there's no relation I can make where I can like get rid of the r and put it in terms of h, right? And the thing is, I actually want to know what the rate of change of r is, so I want to leave that in there. So when I take the derivative, I get a dr dt waiting for me there, right? So I want that. So I actually want to just take the derivative just as it is. So I've got 3 things I got to do now. So let's start taking the derivative of this. This would be dv would be, or sorry, the derivative of the volume would be dv dt. And then I'm going to pull the 1/3 pi out. And then I'm going to do this next part in brackets, just so I can kind of see it more clearly. So I got to do product rule with this, right? Where this r squared is my f, and this h would be like my g. So, okay, this would be r squared, right? Just, that's like f, times the derivative of h, which would be dH dt, plus, and then it's going to be the derivative of r. So what would that be? That would be 2r times dr dt, yep, and then just times g, so h. Okay. Okay, so let's throw some numbers in now, right? Like we know most of these. So dv dt, it was 10, and then we still have 1/3 pi Am I safe to put the radius in now? Yeah, because yeah, we've taken the derivative. I want to know it at this exact moment. So yes, now we can throw it in. So the radius was 3 squared. dH dt, I know that one too. That's 0.02, right? That was how fast it was increasing. Plus 2 times, and then the radius was 3. And then I don't know dr dt, but that's good. That's the one I'm looking for, right? So I'm just going to write dr dt again. And then h, I do know that one at this moment as well. So that's 4. Okay, now the rest is algebra. We just need to solve for that now, right? So, okay, if we, yeah, let's rewrite this again. So this would be 10 is equal to, and then I'm gonna throw like the pi over 3. I'm gonna distribute it into this. Are you guys okay with that? Into this term and into this term. I just want to keep the pi. That's the problem. I don't want to just put it all into decimals yet, right? So I'll throw it into that. So this first part here would be 3 pi, which is just 9 over 3, right? So 3 pi. And then the next part here, I'd like there not to be this decimal. So can we write that decimal as a fraction instead? What would that be?
2 by 100.
Yeah, 2 over 100. Okay, so I'll just leave it like that for a second. Plus, and then if you 2 times 3 times 4 divided by the 3 I'm bringing in, we get 8 pi, and then dr dt. Okay, now the next row, I'm just going to simplify this up. So that would just be 3 over 50 pi plus 8 pi times dr dt. So I'll bring this term over to the left side, so that'd be 10 minus 3 pi over 50 is equal to 8 pi times dr dt. Okay, now I'm going to rewrite this one with a common denominator. So that would just be multiplying this 10 by 50 over 50, right? So that would be 500 minus 3 pi all over 50. Okay, and then at the same time, I'll bring this 8 over pi over to this side too, right? So that'd be like 1 over pi, or just, the 8 over pi is in the denominator, is equal to dr dt. Okay, and then just 50 times 8. That's kind of the last thing I can do here. So 500 minus 3 pi over 400 pi is equal to dr dt. And we're done. And then that's roughly equal to, what is that, 0.39 feet per second.